Here is the definition of a logarithm. We're going to say that the number y is the logarithm, log, base a of x. So here's what we have so far. We have that this number y is the logarithm base a of this number x. And now I'm going to write a double arrow because it goes both ways. So what it's going to say is, if you have this, you can convert it to this. And backwards, if you have this, you can convert it to this. So far we have that y is the logarithm of x, and here's what that means. You can convert that to an exponential, a more familiar term, by writing this. That a to the y is equal to x. Now let's take a look at what this says. It says that this number y is the logarithm of base a of x. If you do this, if you take this base a, right, it's the base, so we write it in the base, raise it to this power, you get that number x. So I'll take this a, raise it to that power, and that will generate that number x. So look at this. What is y? Y is the logarithm, but over here, y is the exponent. So we're going to say now that logarithms are exponents. And I'm going to put this in a box. Matter of fact, I'm going to put it in two boxes because it's that important. And if we remember this, if we're trying to make any conversion, this will help us make that conversion. So logarithms are exponents. Let's do some examples just to see. Let's start with this one. 5 is equal to the logarithm base 2 of 32. Or if the logarithm base 2 of 32 is 5. Now, let's convert this from this exponential, from this logarithmic form to exponential form. We'll do that by using this fact here. Logarithms are exponents. So look what we have here. The logarithm is 5, but logarithms are exponents. So this 5 is an exponent. But of course, exponents go on bases, and over here you can see that number written down below. That's the base. That's a 2. So that's the base. That's the exponent. So we'll write that. We'll write the base 2, put an exponent of 5 on it, and sure enough, 2 to the 5th is 32, which is that number right there. So 2 to the 5th is 32. Here's the logarithmic form. Here's the exponential form. Let's try another one here. How about 3? Now that's the logarithm base 5 of 125. We're going to convert this to exponential form. So what we want to do is going to make this translation here. And what we're looking at then is that the logarithm base 5, right, the base is 5, the logarithm base 5 of 125 is 3. So remember what we have here. Logarithms are exponents. So this 3 must be an exponent. But of course, exponents go on bases, and the base here is 5. So let's write that. Let's write the base 5. We'll put the exponent 3 on it, and sure enough, 5 times 5 times 5 is 125. Let's convert this logarithmic statement to an exponential form. We have the logarithm base 4 of 16 is 2. Now we know, right, we know that logarithms are exponents. Here's the logarithm. The logarithm is 2, so that's an exponent. And exponents go on bases. The base here is 4. So let's write what we have. This is going to tell us that the base raised to that exponent is 16. And sure enough, that's what we're looking at. 4 squared is 16. Now, let's convert the opposite direction. Suppose we're given this exponential form, and we want to convert this to logarithm form. Well, we know that logarithms are exponents, so let's just read what we have up here. The logarithm is the exponent. Now up here, the exponent is 5. So we can say now that 5 is the exponent, right? The exponent, but exponents are logarithms, so I'm going to write log. So I've got this. 5 is the exponent, but I'm going to write exponent as log. And exponents have bases. The base here is 3, so we'll put a little base down there of 243. So what about this one here? 7 squared is 49. So let's write this in logarithmic form. So logarithms are exponents. The exponent here is 2, so we can write 2 is the exponent, but logarithms are exponents, so 2 is the log. The base here is 7, so we'll drop our 7 down there, and the only number left is 49. And let's try another one here. Let's convert this expression here, this exponential equation, into a logarithmic form. So logarithms are exponents. The exponent here is 6, so 6 is the logarithm, so we'll write that. 6 is the logarithm. Now the base here is 4, so we'll write a little 4 down there in our base. And the last number here is 4096. So this translates, this right side says this, that this base to that exponent is 4096. Well, let's do some problems from the textbook. So as I go through these, here's the first problem I see. We have one that maybe looks like this. 10 to the 6th is equal to 1,000,000. And what we want to do is write this as a log form. So let's try this. 10 to the 6th is 1,000,000. So logarithms are exponents, right up here. Logarithms are exponents. So the exponent here is 6. So we can write that this is going to translate as 6 is the logarithm, the exponent, base 10, right? The base here is 10 of 1,000,000. So this will be of 1,000,000 right here. Now, let's make this conversion here. 5 to the negative 3 is 1 over 5 cubed, 125. But we know that logarithms are exponents. The exponent here is negative 3. So we're going to be writing negative 3 is equal to the exponent, log, of the base, right? The base here is 5, so we'll put our little 5 down here, of 1 over 125. And what this side says, this side here says that if you take 5, raise it to the negative 3 power, you'll get 1 over 125. And now here's our translation for this exponential form. 10 to the 0.6990 equals 5. We can translate this to logarithms by writing this. The logarithm is the exponent. The exponent here is 0.6990. That's the logarithm, the exponent. The base is 10, and the number that we have there is a 5. Now we've got 5 to the 4th is 625. We're pretty good at this now, and logarithms are exponents. So the exponent here is 4, so we're going to write 4 is equal to the logarithm. Logs are exponents. The base here is 5, so we'll write our base down there, a little below, of 625. Now in number 5, we've got a logarithmic form, and we want to convert this to exponential form. So we know this. Logarithms are exponents. The logarithm is the exponent. So the exponent's a negative 1, and exponents go on bases. That would be 10. So we're going to put this negative 1 as an exponent on the 10 and write 10 to the negative 1, and that's going to give us this number right here, 0.1, and we'll put in some zeros. Let's make this conversion. The logarithm is the exponent. So this exponent is going to go on that base. So let's write it. We'll have 10 to the 1.8921, and that's equal to 78. Now, how about this one here? Let's convert that to exponential form. So 3 is the logarithm, but 3 is an exponent, right? Logarithms are exponents. So 3 is the exponent, and that goes on that base 3. So we happen to have 2 3's here. So we get that 3 raised to that 3 is 27. And just to point them out here, this 3 here that's the base. This 3 here, that's the exponent. Now what we want to do is just find this number. What is the log base 10 of 1,000? Well, here's what we know. The logarithm is the exponent. So there's going to be this is going to equal some number over here, right? It's going to equal some number, and that number is going to be this. The logarithm is the exponent. So whatever number we put here, that's going to be the exponent for 10 that goes on 10 that gives us 1,000. So we have to make some guesses here. What number do you think you would put here as an exponent to get 1,000? So 1, 2, 3, 4, it turns out to be 3. 10 times 10 times 10 is 1,000. So this is going to be a 3. So we're going to use the same idea in number 9. We want to find what number is the log base 10 of 1. Log base 10 of 1 is what number? Well, we're looking at a logarithm, and we know logarithms are exponents. So what we're maybe thinking here is, right, this is equal to some number, and that number, this number is going to be an exponent. So what exponent would you put on 10 to get 1? So we're kind of thinking this. 10 to what power is equal to 1? And there's really only one number that we can put in there, and that's going to be a 0. 10 to the 0 is equal to 1. In fact, do you remember that x to the 0 is equal to 1? As long as x is not equal to 0. So a non-zero number to the 0 power is 1. Now, what number is this? It's a logarithm. Logarithms are exponents, and exponents go on bases. So what we're thinking is, what exponent would you put on that 3 to get 27? So what we're thinking here, all right, this is going to be some number, and it's going to be the number that we put on that 3 that as an exponent to get 27. So we're thinking this. 3 to what number is 27? So with a little bit of trial and error, unless you know it, you know that that number is going to be 3. Now, in logarithmic notation, it's pretty common to do this. If you have the log base 10 of some number, we're going to omit the 10 and just write log of x. So if you look at something like this and you don't see a base, we assume it to be a 10. Now, on your calculator, you're going to try to use your calculator to get this number right here. This is not one of those ones we can guess. So on your calculator, now I'm using a TI-84, so I'm going to press the LOG button. So when I press the LOG button, I get this. I get LOG and a parentheses. And then I'm going to type in the 16600, no commas, close. Now the parentheses, these parentheses, that one comes automatic. This one you have to put in, and it's right above the 9 key. This log key is in the very first column, a few up from the on key. So when I press enter for that, I got this number here. I got let's see if I can get it. I got 4.2201, and we're going to round to 4 decimal places. So what we're saying here is this, that the logarithm base 10 of 16,600 is 4.2201. And here's what it would mean. Here's the logarithmic form. If we convert this back to exponential form, where the logarithm is the exponent, so that exponent on 10 would give us that number right here. That is 10 to the 4.2201. That's going to give us 16,600, or almost, because this is rounded off. So now on our calculator, we're going to compute the log of 0.15, so we're going to press the log key. This is how I would do it on my TI-84. I'll press the log key, and when I press that key, what I get is log and a parentheses, and then I'm going to type in the 0.15 and a closed parentheses. So 0.15, and the closed parentheses is right above the 9, and then when you press enter, I'm getting negative 0.82390 ... but we're going to round this to 4 decimal places. So I'm going to write this as negative 0.8239. And just so we're clear on what it means, is what we've said is the log base 10 of 0.15 is negative 0.8239, and this means that, right, the logarithm is the exponent. 10 to that exponent, so let's write it, 10 to that exponent, negative 0.8239, should give us really close to that 0.15. It won't give it exactly because we rounded this off. Well, now we've got a logarithmic equation. We want to solve this. Log base 2 of 8 is equal to what? Well, here's how we're going to do this. We're going to keep in mind that logarithms are exponents. And so if we read this, the logarithm is the exponent. The exponent goes on the base. So let's write this. The logarithm is the the exponent. The exponent will go on that base of 2, and we'll have 2 to the x equals 8. Now, we're going to pretty much guess a solution here. 2 raised to what power will give us 8? Well, it turns out that it's 3. Right? 2 times 2 times 2 is 8. There we go. So here's another logarithmic equation, but the x is now here rather than over here. So let's convert from logarithmic form to exponential form. That will give us, right, the logarithm is the exponent. So the exponent is 4. It goes on that base of 3. So we're going to have 3 to the 4 is x. And 3 to the 4th is 3 times 3 is 9, times 3 is 27, times 3 again is 81. So x is 81, and we've got it solved. Now, same thing here, another logarithmic equation, but now the x is in the base. So let's convert to exponential form. So we're going to have x to the 2 is equal to 4, right? Logarithm is the exponent, so the exponent goes on the base, and it's equal to 4. Now, what number do you know that if you square it, you get 4? Well, I think we all know that that's a 2. So here's what a graph of a logarithmic function would look like. It's going to look like this. Here's x and here's y. And right here, this is a 1. And what you know here is that the log, any base of 1 is 0. Right? Now, do you believe that's true? The logarithm is the exponent, so the exponent of 0 would go on that base, so b to the 0, and sure enough that's equal to 1, as long as b is not 0. Now, in the number 16 I'm looking at, we're given 4 graphs, and we want to know which one of these could be the graph of this function right here. Well, at least for mine, I can rule out b. Let's rule these out. I can rule out b, because b looks like this, kind of like this. I can rule out c, because c looks more like an exponential function. Okay, so what about a or d? So we're going to look at a and d, but we know this. If we take, say, y equals just the log base 10 of 0, that's equal to 1, right? Log base 10 of 0 is equal to 1. Log of 0 is always equal to 1. So what we would have is just this so far. If we just had this function, log base 10 of x right at 0, y would equal 1. But what we have is 7 times that. We have 7 times that 1. So we're looking at y equaling 7. So look at your graphs and see if one of these, a or d, seems to pass through 7. So your graphs are probably going to be different because these problems pop up differently every time, but mine is going to be graph A. This is how the Richter scale readings work. The Richter scale number for an earthquake is given by the log of this expression here, where I sub O, I naught, I sub 0, I sub O, this is the least intensity that the instrument is able to pick up. And this is the intensity, say the amount of shaking on the earth, that is occurring. So we're going to compare the amount that's actually occurring to the least intensity, take its logarithm. Now, suppose we have an earthquake that has this intensity. It's 100 million times the least intensity. So let's take this value of I and put it right in here, and let's see what happens. We're going to get R, the Richter scale reading, is equal to the log of, okay, I, which we're given to be 100 million times I naught divided by I naught, right? It's our 100 million I naught divided by I naught, 100 million I naught divided by I naught. And what do you know? The I naughts cancel. And now we're left with R equals the log base 10 of 100 million. Now, if we convert this logarithmic statement to exponential form, we're going to have, right, the logarithm is the exponent. So r is the exponent on 10. That's going to look like this. 10 to the r is equal to 100 million. Now, this is just the power of 10. It's the power of 10. So just look at the 1 and count the number of zeros. I've got 3, 6, 7, 8. There's 8 zeros. So this is going to be that 10 to the 8 is equal to 100 million. So in this case, R, the Richter scale reading here, is an 8. This is an 8.0 earthquake.